All right, so in this lesson, we are going to solve a system of equations. Solve a system of equations using a substitution method. So I'm just going to, a substitution method. So there are a few ways to use substitution to solve a system. I'm going to show you one of the ways. So y equals 4x plus 6 and y equals negative 5x minus 21. Remember, we're looking for the x and the y that make this equation true and this equation true. So what I would like you to think about is, let's go ahead and just make this one green. Y equals 4x plus 6. And we'll make this one yellow. So y equals negative 5x minus 21. I essentially want to know when y, this y, will, I guess we can use this, will be equal, now use blue, will be equal or equivalent to this y. So we'll call this one y2, well, we'll call this one, we'll start from over here, we'll call this one y1. So we want to know when y1, and we'll call this one y2, is equivalent to y2. So y1 is 4x plus, it's equivalent to 4x plus 6. So I'm just going to go 4x plus 6. We want to know when that, I should probably make that a little better, plus 6. Okay, we want to know when that will be equivalent to y2, which is equivalent to negative 5x minus 21. So I'm just going to go ahead and do that math. So because we only have x's, so now we can actually just solve. So plus 5x, and I get 9x, plus 6 equals, no, that's gone, negative 21. And then I'm going to subtract 6 from both sides, and I get 9x equals negative 21 minus 6 is, I should make that a little nicer. Okay, now or easier to see or understand, equals negative 27. So negative 21 minus 6 is negative 27. I divide by 9. I get x equals negative 3. Now, remember, I have this x. For this x, it takes the same y to make this equation true and this equation true. So it doesn't matter which equation you use. I will use this one over here. Y equals negative 5x minus 21. Don't forget that we're using this x right here because we know this is the x. This is the x. That with the other y will make this equation true. So this x is negative 3. And the rest should stay the same. So y equals negative 5 times negative 3 minus 21. A negative times a negative is a positive 15 minus 21. So y equals negative 6. Cool. So my solution, of course, will be, let's make this one pink, negative 3 comma negative 6. Solution will be negative 3, negative 6. All right, so the solution to this system of equations is negative 3, negative 6. This means negative 3, negative 6 will make both equations true. Visually, both lines of solutions will intersect at this point. Just like when we did the graphing, like how we graphed all the dots and it made a line, same for the other one. And then we looked for the one that they shared by looking at where the lines of dots intersected. All right, so let's go ahead and prove this. Remember, this is -3, -6. So my first one was green, so I'll use that. Y equals 4x plus 6. And so the x becomes, or I should do this, the x becomes -3. And the y becomes -6. So -6 equals 4 times -3 plus 6. A positive times a negative is a negative. And -12 plus 6 is -6. So it works for that one. So -3, -6 works for this one, for that first equation. Let's prove that it works for the second one also. So this one is y equals -5x minus 21. That, oh, we're keeping the same one, so pink. That x is -3. That y is -6. So -6 should equal -5 times -3 minus 21. Negative times a negative is a positive. And 15 minus 21 is -6, which is what we're supposed to get. Because -6 equals -6. Cool. Let's go to the next page. So on this one, I'm going to start you off, but I assume that you know how to do this. We did this in the other one also. So I'll start you off. So y plus 5 equals 4 times x plus 3, and x plus 3y equals -5. Neither of these are in slope-intercept. Neither of these say y equals. So I'm going to make that first one say y equals. So y plus 5 equals 4 times x plus 3. I'm going to distribute here. I get 4x, and right here plus 12. That will be equivalent to y plus 5. And then to make this say y equals, all I need to do is subtract the 5. So y equals 4x. 12 minus 5 is positive 7. Equals 4x plus 7. So we're good there. But now I need this one over here to also say y equals. So x plus 3y equals -5. I'm going to subtract x from both sides so that I'm left with the y's right here. So 3y equals -x minus 5. Now I'm going to divide by 3, both sides by 3. Y equals, so remember, don't forget that 1. A negative divided by a positive is a negative. I wanted to make that look a little nicer. So don't forget that 1. So a negative divided by a positive is a -1/3. It's not 3x, it's -1/3x. And a negative divided by a positive is a -5/3. Okay, so we have our two equations. Let's make them equal to each other. So 4x plus 7. We are trying to see when that is equal to -1/3 x minus 5/3. So we have some fractions. Let's just get rid of those, okay? So I'm going to multiply both sides, or the whole thing, by 3. So 3 times 4x is 12x. 3 times plus 7 is plus 21. Positive times a negative is a negative. 3 times 1 is 3, divided by 3 is 1. And a positive times a negative is a negative. 3 times 5 is 15. 15 divided by 3 is 5. Cool. So now I just got to solve right here. So plus 1x plus 1x. I get 13x plus 21 equals negative 5. Now subtract 21 from both sides. Get 13x equals negative 5 minus 21 is negative 26. Divide by 13. And I get x equals negative 2. Now once again, this is just the x. I need the x and the y that make both of these equations true. I don't really like messing around with this one too much. Kind of annoys me. So I'm going to use this standard form. So I will put this yellow one here. So x plus 3y equals negative 5. And for x, I'm going to put negative 2. And it seems to make no difference. I don't need parentheses around it. Plus 3y equals negative 5. So plus 2, it looks like I should do plus 2. So I get 3y equals negative 5 plus 2 is negative 3. Oh, that's handy. Divided by 3. Divided by 3, and y equals negative divided by positive is a negative 1. So my solution is negative 2, negative 1. All right, and I assume that you know the statement, so let's not bother with the statement. I want to show you the proof. So we have, well, let's write our solution first, which is negative 2, negative 1. And let's go ahead and use green, so 4x plus 7. Oh, y equals 4x plus 7. Oh, wait, I can't. I have to use the original. I wanted to use these two, but I have to use the original. So y plus 5 equals 4 times x plus 3 and x plus 3y equals negative 5. Theoretically, you could use these if you did them right, but you're never quite sure, so you need to make sure, because we care about, like, we need to make sure, and one way of making sure is using the original equations. So let's do this. So negative 2 is the x. So negative 2, y is negative 1, x is negative 2. Oh, I forgot the arrow. X is negative 2, y is negative 1. Okay, so I have negative 1 plus 5, and that should equal 4 times negative 2 plus 3. And on this side, I have negative 2 plus 3. Ooh, I'm going to need parentheses here. 3 times negative 1. And that will equal 5. So let's do this math over here. Negative 1 plus 5 is positive 4. And then I get 4 times 3 minus 2 is 1. And of course, 4 equals 4. Cool. And over here, I end up with negative 2. A positive times a negative is a negative 5, negative 3. And then, oh, I forgot this negative here. So I can't go back. I'm just going to have to put it there. Negative 5. And negative 2 minus 3 is, in fact, a negative 5. Nope. I don't know why I did that. I was just writing it again. So negative 5 is, negative 2 minus 3 is negative 5. And that, in fact, equals negative 5. All right. One more page of